go back. All right, good. It finally came back up. Okay, does anyone else come in since I called roll? Sorry, I've been fighting with the new computer, but it seems like we're on the same page now. All right. Any questions for anything we've covered so far? Okay. We were on example 7 on page 186. This is chapter 4, Rational Expressions, 4.1, Simplifying Rational Expressions. And let's see if, I guess that's all the screen we got. So let's see, my pen's not activated. And I'm not seeing where we can activate it. Is it here? No. There used to be an icon down here that I could click on, and it's not. Oh, this is not very good. Okay. Well, I guess it's not working too well on this new computer. I can't get my pen. Do any of you have any experience with ionizing pens? Oh, come on. Can't get the pen activated, and I don't see how to do it. So I guess we'll go without. We're recording, so it'll get the sound, but it won't get the pen. I don't know why the pen's... Wait. Here's something down here. No? Let's see what this is. Nope, that's nothing. I have to get help over... I don't want to waste any more class time. Let's see. Can I even get this to do? This may work. Let me try this. Let's do current slide. Okay, we go back to this mode, so maybe the pen will work now. Pointer options, pen. Okay. More pointer option, ink color, black. Okay. Well, this is better than we had. Okay. Now again, now my screen is even smaller, but let's go from here. Example 7 on page 186. Negative 28 a squared. Before we get into this, I meant to say this about the test because a few people have been asking, but those who've been asking aren't here yet. Goodness gracious, that looks small here, it's huge there. I've got the test marked, and those that I was pretty certain you had completed, either because you told me or whatever, I've got the grades in my grade book. I don't have them in Blackboard yet. But there were some I couldn't tell if you were going to come back. A few people said coming back and that type of thing. JT's here. But a few people didn't put that but left an awful lot blank. So I didn't want to record a grade for you if you were coming back. So if you did leave some answers blank and you want to continue working on them, I can let you do that because I've made that offer to everybody. So I want you to score as well as you can. Okay. So if you do want to work some more on it, please let me know. Hopefully before the end of the day today, I don't know how long that'll be, but before the end of the day today, I'll have the grades on Blackboard. I do have 2 hours of office hours this afternoon, and as far as I know, I don't have any scheduled interruptions, which I don't know if that's even a real life thing. If it's interruption, it's usually not scheduled. But I hope to just be able to complete grading. I've got yours graded and the next class graded, but I've got 2 other classes that I'm working on. Get those grades done and get everything in Blackboard. Okay? Now, that said, there's one other thing I wanted to alert you on. Change of office hours. Not today and not Wednesday, not Friday, but Tuesdays and Thursdays. I just finished the first mini-term physical science class. Okay? That made my only office hours on physical science 12:15 to 1:15, which is also my lunch hour. That's the only time I had to be in the office on Tuesdays and Thursdays. However, I'm starting the second mini-term tomorrow. And therefore, that class has a bunch of automotive students who are just coming back from their co-op quarters at the dealerships, and some of them are taking the physical science. They have courses over there that run until 3 o'clock. So I couldn't start their physical science class until 3:15, which means now I have office hours on Tuesdays and Thursdays from 1:15 to 3:15 that I did not have before. Of course, that means I'll be here until 8 o'clock. I was here until 6 o'clock before, but that's fine. You know, for office hours, I'll do it, right? So anyway, that's one big change. Tuesday and Thursday, office hours 1:15 to 3:15. On Monday and Wednesday, 3:15 to 5:15. On Fridays, 7:45 to 11:45, unless there's meetings and stuff. All right, let's get back to this. Minus 28a squared b squared divided by negative 63 a squared b cubed. Now, in problems like this, it's important to read the directions, what it says to do. This is page 186, chapter 4, section 4.1, example 7, bottom of the page. All right. This problem, all it said was simplify. So that, to me, means write this in the simplest form. In some other context, sometimes it'll say things like having no negative exponents or things like this. Whatever the problem asks for, do it that way. This one, we're just going to simplify as much as possible. And Tara's here. Okay. Now, where would you begin simplifying? There's several places you can start. Where would you begin? You tell me. Okay, see if you can reduce that. That sounds like a great idea. What actually comes first, in my mind, is the sign, which you don't have to do yet, but I like to take care of signs first. They're out there in front, so let's take care of them. What's going to be your answer? Positive. So we're going to leave off the signs altogether, because negative divided by negative is positive, so that. So now we move straight to this. What do we look for in 28 and 63? Common factors. Do you see any? Well, 7. So let's divide a 7. Let's first make these pluses. Divide 7 and 28. What's that? 4. 7 into 63? 9. So we have 4 ninths. Anything else? The a squared divided by a squared is 1, or a squared over a squared is 1. Perfect. Take out 2 b's from the top, 2 b's from the bottom, and that leaves you 1 b on the bottom. Right? There you have it. 4 over 9b. Okay? Now, if maybe, I don't remember any of these, but if they ever said, don't leave any variables in the denominator, then you could write this as 4/9 b to the minus 1. But far more frequently, they'll say, don't use negative exponents. Oh, got it. Andrea. Good deal. Anyone else come in since the call roll? Okay. Good deal. Let's see how the book did. Good for them. They got it right. How about this one? X squared plus 4x divided by x squared minus 16. Now this one's a little different because this is a binomial. Monomials are pretty easy to work with. Binomials are hard, but they're a little different. What would be your approach on the binomials? Any idea? A little louder? I heard something about 4. Factor it. I love it. Let's factor it. How can we factor that numerator? In fact, I say factor everything in sight when you're dealing with these. Does the numerator factor? How? X times x plus 4. There's your 4, okay? How about that denominator? X times x minus 4 plus 4. Now what do you look for? Common factors, do you see any? X plus 4 and x plus 4, they go away. And your answer is x over x minus 4. Okay? Now, this book at this stage doesn't require you to do this, but I still think it's a pretty good idea. In fact, these are just simplifying expressions. You've done it. If this was an equation, then I would also have said a can't be 0, b can't be 0, x can't be plus 4, and x can't be minus 4. Even though the answer, there doesn't seem to be any problem with a being 0 because it's not in the answer. But if it's in the original problem, it still couldn't be. So these are just expressions we're simplifying, so don't worry about that yet, but it's a good practice to start thinking about. All right, any questions? And they got it right, good for them. How about the next one? 4a squared plus 12a plus 9 divided by 2a plus 3. What would be your approach here? By the way, we're on page 186, chapter 4, section 4.1. I'm sorry, 187. And this is example 9. Factor everything in sight, absolutely. The top specifically because the bottom's not factorable. So you can write that down as 2a plus 3. All right. Now, you want to, okay. What do you think about that numerator? Does it look like it might be factorable? Yeah. How? 2a times 2a and plus 3 times plus 3. Can it be that easy? Let's hope so. I just wrote really poorly. Okay. Let's see if it works. Don't ever just factor and then go check. 2a times 2a is 4a squared. 2a times 3 is 6a. Plus 6a is 12a. Plus 9. Got it. Now what can we do? Divide out one of the 2a's plus 3, and that leaves you a 2a plus 3, and that should be your answer. Yes, it is. Any questions? Okay. Let's erase all the ink and go back to Example 10. 5n squared plus 6n minus 8 divided by 10n squared minus 3n minus 4. What would be your approach here? Factor, factor, factor. Let's start with the numerator. Is it factorable? We don't know. If it is, what would be your possible factors? A little louder. I heard something, but I couldn't make it out. Help me, folks. It's the only possible factorization for 5n squared. 5n times n. Okay, got it. Where do we look next? Sign of the last term. What is it? Negative. What does that tell you about these two signs? Got to be different. One's a plus, one's a minus. You have a preference? Well, tell me what to write. Put the plus after the 5n. Okay, let's try that. The minus after the n. Now, possible factorizations for 8. We have several. What would be your first guess? 4 and 2. In that order? Let's try it. Okay? Let's check and see if that works. 5n times n certainly is 5n squared. 5n times negative 2 is negative 10n plus 4n would be negative 6n. But the good news is, what are we missing it by? Got the right numbers, just the wrong sign. So what do? Change signs. Switch signs. That's exactly right. So let's make the minus here a plus and make the plus there a minus. Wait, I said it backwards. The plus, a minus, and the minus, a plus. So let's just check it again. 5n times n is 5n squared plus 10n minus 4n plus 6n minus 8. We got it. For the numerator, how about the denominator? There's a lot more possible factors here, aren't there? So what might we want to try? Say again? 5 and 2, okay? I certainly like that idea. 5n and 2n. Okay? Remind me?
Sheffield.
Huh? Sheffield, got it. J. Just got to find you on the page here. Okay. What next? Where would you look? Sign of the last term. Negative. What does it tell you about these two? Negative and positive. I would say try it in that order. Okay? And then what would we have? 4 and 1. Now, I don't know if you're doing that by the same reason I am, but frankly, what I like to do is once I've got one thing factored, I am a wishful thinker. I sure hope one of these factors shows up down here. Why not 5n minus 4? Let's see if it works. 5n times 2n. 10n squared. 5n times 1. Second. 5n. Minus 8n. Negative 3n. Look at that. And then minus 4. Got it. Now what can we do? Divide out the 5n plus 4. Minus 4, and that gives us n plus 2 over 2n plus 1. Question, is that in simplest form? Can we do anything else to it? What? Say again? No, you can't. Okay? Now, I shouldn't even say this since y'all are so on the ball with it, but I've seen students in the past, where they weren't nearly as bright as you, who have tried to somehow cancel out ends or something like that. Don't try it. You never are canceling anything out. You're dividing out things. You can only divide out things that are multiplied. This is added. You cannot divide out things that are added. This is added, or this is multiplied here but added there. You have to factor it out so you have it multiplied by numerator and denominator before you can divide it out. So don't try going around wiping out as much as you can. Just not legal. Your answer is n plus 2 over 2n plus 1. Fantastic. Any questions on that? Okay. Well, I didn't do that before, but I'll do it now. How about this one? 6x cubed y minus 6xy. Sorry about my voice. I went to the UAB game on Saturday. Sorry. X cubed plus 5x squared plus 4x. Where would you begin on a problem like that? Factor out everything you can. Greatest common factor in the numerator, what would it be? 6x, y. I thought that's what you said, right? Okay. All right. Notice there's a 6 in each term. There's an x in each term. And Melva is here. Oh, yeah, okay. All right. So factor out greatest common factor. Now, if you don't see it, go on and factor out what you do see, then look again. It may take you several steps, but that's the greatest common factor here. What do you have left in the first term? X squared. Then what do you have? Minus 1. Perfect. How about that denominator? Take out an x, okay? What do you have left? X squared. Say again? Plus 5x plus 4. Okay? Are we through factoring? Say again? No, I don't think so. Let's go on and get rid of the x's because you're obvious those are common factors. So get rid of those. Leaves you in the numerator 6y. But what can we do with x squared minus 1? X plus 1 times x minus 1. Does everybody see that? Okay. How about the denominator? We got rid of the x, so what do we have left? Possibility here. Okay, x and x. And you're hoping it's going to be an x plus 4 and an x plus 1? That's a good hope. Why? Because we have an x plus 1 up here as well. Let's see if it works before we do that, though. X times x, whoops, x squared, plus x, plus 4x, and plus 5x, plus 4, 4. It works. Now we can divide out the x plus 1's. And that leaves us with 6y times x minus 1 divided by x plus 4. Is there anything else we can do to simplify that? No. Don't even try it. Okay? Always try, but don't force it. 6y times x minus 1 over x plus 4. Now, they make a mention here that in this last example, you could have gone back and multiplied this, distributed the 6y across. My question is, why would you? You factored it, you simplified. It's no more simple to leave it like this than to multiply through, So why take an extra step if you don't need it? Be lazy. No. The other thing is it just doesn't make it any simpler. Doesn't make it any more complicated, but it doesn't make it any simpler either. So generally they'll leave it in factored form rather than go back and multiplying through. Now, there is another little thing here at the bottom of the page, but it's not on the PowerPoint. Okay? So let's do this, and there's one more example that will illustrate it. So let's go with this. All right. What is 6 over negative 6? That's negative 1. Perfect. Okay? How about negative 8 over 8? That's a negative 1 as well. Okay? How about a over negative a? What you got there? Negative 1 again. Even though you don't know what a is. Any a, if you divide it by itself but opposite, it's going to be negative 1. But how about this one? A minus b over b minus a. Say again? No, it's not 0. It's going to be negative 1 as well, and here's why. What if you multiplied the denominator and the numerator by negative 1? But only do it once. That doesn't change the form, right? So this will be a minus up here, a minus b. Down here, though, let's really multiply through and make it minus b plus a. Well, that's going to be minus a minus b over, and when you rearrange the order here, a minus b. So sure enough, that's also negative 1, because this is the opposite of that. If you multiply one of these by negative 1, you get the other. So therefore, just like here, if you multiply either one of those by negative 1, you get the other. And that one, and that one. Same thing here. You don't have to go through this step. If you ever see a subtraction divided by the opposite subtraction, exactly reversed, you know there's a factor of minus 1. So you don't have to go through this anymore. Just pull a minus 1 out and cancel the rest of them out. So that, like you said, is minus 1. Okay? How about this? X squared minus 4 over 4 minus x squared. Say again? That's negative 1 as well. Okay? Now, you could have factored both of those, but you would have gotten right down to where we were before, and you have minus 1. So anytime you have a binomial expression that the only difference between numerator and denominator is the reversal of the subtraction, you know that's going to be a factor of minus 1. So anytime you have same coefficients, which is signs difference, check them and see if you can divide out a minus 1. Okay? So let's get to the last example, and that's example 12 at the top of page 188. Okay? 6a squared minus 7a plus 2 divided by 10a minus 15a squared. What would you do with a problem like that? Okay, that sounds like a good idea. Okay? While we're there, though, what might we do with the top? Say again? Factor it. Let's see. I just don't like to write as much stuff as I don't have to, so I don't want to write the same thing. Let's see if we can factor it. Oh, no. How would that factor? Any possibility? Maybe we'll go to the denominator first and rearrange it. What do you mean by rearranging? Negative 15a squared plus 10a. Is that what you said? Good. All right. I'm not writing the numerator yet. We're still going to hold off and factor it. But I'm waiting to do it until I find out what else can you do now that you've rearranged that. What's sort of messy about it? Leading out by a negative sign. So what could you do to change that? Factor out a minus 1. And what would now your denominator be? 15a squared minus 10a. You factored a minus 1 out of both the terms in that denominator. Okay? Now what might we do with that denominator? We got a minus out front. We haven't factored the numerator yet. What would this be? Take out a 5a. Okay? And what do you have left? 3a minus 2. Now, does anyone see why I may have not factored the numerator yet? What do you hope is the factor of that numerator? 3a minus 2. Will 3a work here? Yes. Will minus 2 work here? Yes. So let's try it. That's what we want. Let's see if we can get it. A 3a minus 2, what would that leave your first term here to be? How do you, if you divide 3a squared into 6a, what would you have? Little 2a. And if you divided a minus 2 into a plus 2, what would you get? Negative 1. Very good. But don't stop there. Check and see if it works. 3a times 2a is 6a squared. 3a times minus 1 is minus 3a. Adds 2. Minus 7a. All right. And minus 2 times minus 1 plus 2. Yes, it works. So what can we do next? Divide out the 3a minus 2. That leaves us a minus 2a minus 1 over 5a. Now that's a perfectly good, legitimate answer. However, there is another way to write it if you don't like the minus sign in front. Then flip these over like we were just talking about. You could also express that as 1 minus 2a over 5a. That's another perfectly correct answer. You just multiply the minus here, distribute the minus across the numerator. Even though it came from the denominator, who cares? It's out front now. So minus 2a plus 1, so write that as 1 minus 2a. Now this is no simpler, but I just want to let you know. You could also split this into pieces and say 1 over 5a minus 2 over 5. Because a should be cancel out. But that's a little more advanced. You don't have to do that. My guess is this is the answer they put, but this would be perfectly correct as well. Oh, and they put them both. Chris. Just because Chris came in. But there he is. Chris. All right, good deal. Is anyone else coming in while I was paying attention to the board or not? You logged in. I got it right. All right. And they put both answers. Either answer is perfectly correct. Let me give you a hint, though. When you're doing the back of the book, you're probably only going to put one answer, okay? Because they aren't going to take up extra room to put another answer in there. So you just be able to say, well, that's not the answer they got, but can I get it out of it? Yeah, I can. Now this, though, again, reflects one of the issues I have. Oh, and by the way, I've had this done for a couple of weeks now. I forgot to tell you. Your those of you who have WebAssign and like using it for examples and that kind of stuff, if you check your email, check Blackboard, and on Blackboard there's supposed to be a message. I can't see the student side, so I can't tell, telling you what the access code is for the Blackboard account. This book is out there on so if you wanted to use WebAssign, you certainly can. Please use it. You paid for it already when you bought the book, and but they didn't give you. They gave you a code, but it was inaccessible until they did this. And I finally got them to do it and give you a code to get that done. So you can check. I think it's Blackboard. It's where they said it would be. They put a message there telling you what the code is. If you can't find it, I will look and see if I've got it on mine. Again, when I put grades in. And for those who came in a little late, I've got all your papers marked, those who took the test. All of them are marked. But some people left some blank, but you didn't indicate whether you're coming back or not. Others said you were coming back. In fact, one said he was coming back Friday. I took the paper over to the Birmingham campus, and I never saw him. So I've still got your papers. So I recorded in my book if I thought you were through, but if I thought you might be coming back, I didn't put that. Now, I don't have them in Blackboard yet. I'm hoping today, in my 2 hours office hours, I'll be able to finish grading. I've got your class graded and my next class graded, but I've got 2 more classes to finish grading. As soon as I can get those grades done, I'll put them in Blackboard. And if you see your grade there, as far as I know that's your final grade. If you still want to come and do something, we can change it. If you don't see a grade there, that means you either didn't turn in a test or haven't taken a test, or I couldn't tell if you're through or not. So come see me and let me know, yes, I'm through, I'll take that grade. I'll show you what it is, and then I'll give you the option of continuing working or not. Okay? So, hopefully that'll be done before the end of the day today. I just don't know how late the end of the day will be. All right, any questions on this? But what I was going to say about WebAssign, those computerized packages like that, they never give you an option of answers. They only have one answer, and if you don't write it in that form, and there's nothing magical, this form is no better than this one, that one's no better than this one. They're both perfectly correct answers, but in WebAssign, they would have one of them is correct, the others they'd say incorrect. And then you think you missed the problem, and you didn't. You got it perfectly right, you just didn't get the answer they were looking for. When, I don't know, I've heard people tell about teachers in grammar school, middle school, high school, somewhere, nope, if you didn't do it my way, that's not right. You know, that's not how it works. If you get a right answer, it's a right answer, okay? Both of those are right answers. They are the same answer, by the way. Homework exercises. Do any of the odds 1 through 7, any of the odds 9 through 49. There's a whole passel of them there. Do some of the monomials, some of the binomials, some of the trinomials. Do some of every type. Then do some of the odds 51 to 57. And those I'm pretty sure you're going to need, factoring by grouping. And then do some of the odds 59 through 67. Now, I don't know if any of you say, wait a minute, we did factoring before, we don't do that anymore. Math builds on itself. Just because you've already been tested on factoring doesn't mean you're through with factoring. You're going to be doing factoring the rest of your life in mathematics, because that's an important feature. So this isn't like, I don't know, history, psychology, or something that you might, once you're tested on something, you're not going to see it again. In math, you'll see everything again. All right, any questions? All right, let me, All right, finally. This is a loaner computer, and it doesn't operate the same way my other one did, but I'm glad to have it. Well, sort of glad to have it. There we go. Okay. Let's move to 4.2. For some reason, it decided to shut itself down rather than giving me an option on the next slide. Okay, let's do slideshow to current slide. Sorry. All right, we're still dealing with rational expressions. We're now going to be, we first, 4.1 was simplifying rational expressions. Now we're going to multiply and divide rational expressions. Now this isn't the order you did your operations back in grammar school, is it? Didn't you learn to add and subtract first, then multiply and divide? Well, in rational expression, these are easier than adding and subtracting. Because with these, basically it's almost what we were just doing. Factor everything in sight, simplify, and go for it. With dividing, there's one more step, but it's pretty easy. Adding and subtracting rational expressions, you've got to get least common denominators. So that's a little more involved. So this is actually the next easiest thing to do is multiplying and dividing. So we'll multiply rational numbers, just like we started with simplifying rational numbers. We'll multiply rational expressions, then we'll divide rational numbers, then we'll divide rational expressions, and then we'll simplify some problems that involve both multiplication and division of rational expressions. So let's start with rational numbers. We define the multiplication of rational numbers in common fraction form as you got A, B, C, and D, all integers, except B and D cannot be equal to 0. Guess where they're going to be? Denominators. That's why they can't be 0. So if you have A over B times C over D, how do you multiply these fractions? Multiply numerators, multiply denominators, simplify. That's how you do it. You can't get much easier than that. Except if you had any common factors between any numerator and any denominator, you could divide them out first, and then you don't have to simplify at the end. It's usually easier to do it here than it is there. But we'll see that. Okay? So here's some examples. Okay? How would you multiply 2/3 times 4/5? 4 times 2 is? 8 over 15. Perfect. This one? Now, here's what I suggest. You don't have to do it my way, but my suggestion is count your number of negative signs. You could have had 1, 2, 3, or 4 of them, okay? If you have an odd number of negative signs total, your answer is going to be negative. Even number of negative signs, positive, okay? So deal with the negative signs first. The answer is going to be negative. Okay, continue. Negative 15 over 28. Got it. Okay, how about this one? Negative 65 over 18. Look at you. You all look good. And knock things off the wall. Okay. Okay. Any questions? Pretty simple, huh? Now, we also agree when multiplying rational numbers to express the final product. This is what I was saying before in reduced form. The following example shows some different formats for doing that. Okay? Frankly, why write this down again as a multiplication here when you could have divided out to begin with? Okay? With multiplications, you can divide out to begin with. So if you started this and just saw common factor 4 and 4 between numerator and denominator, divide it out, that leaves you 2 sevens. This one, a little more involved. Now be careful with this, and let me show you what you need to be careful for. You're dealing with numerators and denominators. No common factors here and none there. But there are here. 8 will go to 8 one time, 8 will go to 32 4 times. That's what they did. A good idea to put the 1 there. Sometimes we just cross that out and then pretend it's not there anymore. Remember, it's a 1. 9 will go into 27, 9 will go into 9 once, into 27 3 times. Then multiply numerators and denominators 3/4. Okay? Does that make sense? If this looks confusing to you, do it a simpler way. Okay? Don't overcomplicate things. Take as many steps as you need to get a right answer. It's much more important to get right answers than to be quick about it. A fast, wrong answer is worse than a slow, right answer. Okay? Always. All right. How about this one? First, what would you do? Deal with then science. What's your answer going to be? Positive, okay? You can forget about your science then. In fact, I usually go make them both positive. Now, they did something different on this one. What they did was a complete factorization. I'll show you how they did it, or how I would have done it if I were assuming this is how they did it. 2 will go into, okay, back to prime numbers. Remember how we did that? What's the smallest prime number that will go into 28? 2. 2 times what? So here's your 2. 2 times what? We give you 28. 14. Well, 2 go into 14? Yes. 2 times 7. So you got that one done. 2 won't go into 65. 3 won't go into 65. 4 won't go into 60. Well, 4 is not a prime number. But 5 will go into 65. How many times? 5 will go into 6, 1. 5 will go into 15, 3 times, 13 times. Okay? Let's do the same to the denominator. Smallest prime number will go into 25. 5 times what? 5, both on prime. Move on to this one. Smallest prime number will go into 78. 2 times what? 2 will go to 78 how many times? 39. Yeah. Okay. Use your calculators if you need to. Okay. 39. 2 won't go into 39. Will 3 go into 39? Yes. 3 times what? 13. 13 is a prime number. You've gone as far as you can. Now let's look at what you got next. Well,
is there no other way to find it out?
What's that?
Is there another way?
Yeah, I'll show you that in a minute. I'll just show you the way they did it. The 2's go out, they've been dating. The 5's go out, and the 13's go out. That leaves 14 over 15. Okay, how I would do this is similar to what we did in the last problem. I don't recommend this. This is just how I would usually do. I would say, let me get my pen back. Pen and ink color and black. Okay. I would look at this and say, I know 2 will go into 28 14 times, right? 2 will go into 78. How many? 39 times. Okay? That's all I can do there. What will go into 25 and 65? 5. Okay, first I said minus times minus is plus, okay? 5 will go into 25. 5 times. 5 will go into 65. Use calculators if you need them. 13 times, okay? Do you see any common factors left? This is a 2 and a 7. No 2s or 7s down here. But look at here. 13 will go into 39 3 times, and 13 will go into 13 1 times. 14 times 1 is 14. 5 times 3 is 15. That's another way to do it. I don't know if it's any easier. I kind of like it better. That's just an awful lot of work to do all that dividing out and then have to multiply some together at the end. That's just extra work, and I'm lazy, so I don't like to do extra work. Okay. But it's real easy to get lost here, and forget to mark something out. So do whatever you're most comfortable with. Okay? So 14/15. Now, what if you had rational expressions, not rational numbers? Okay? So multiplying rational expressions, multiplication of rational expressions follows the same pattern as multiplying natural numbers in common fraction form. That is to say, we multiply numerators and multiply denominators, expressing the final answers in simplified or reduced form. I don't like that instruction. I would say factor everything in sight. Get rid of common factors, then do your final product. You'll be in simplified or reduced form. Okay? Here's how they did this one. 3x, well, let's see. How would you do that? You tell me. You do a complete factorization? If you would, we can. Perfectly fine to. Let's show you, says whoever. 3 factors is 3 times 1. Can't do anything with this. How about 8? 2 times 4. The 4 factor is 2 times 2. So, okay, they went on to put 8 here. I can't figure out why they do it this way. Okay, 3 times 8. That's all they did. And x times y squared. Go write it like this. Do complete factorization. I mean, if you're going to cancel out like this, I'd have canceled back here. But either way, we don't have it. This is 4 times 9 times x times y. Okay? 3 will go to 9 3 times. 4 will go to 8 2 times. Now, they didn't put their 1s up here. It's okay not to, but it's usually a safe thing to put 1s there. X will go to x 1 time. I will put 1s there too. Y will go into y squared y times with a 1 down here. So what do you have left? 2y divided by 3. And that's all, folks. So you can split them out like this, or you could do your division like this. Frankly, I would have done this. 3 will go into 9 3 times. I'd probably put it. Here's the only problem with putting 1s up there. You'll see it in just a second. X will go into x 1 time. Now, if I put a 1 up here, you might mistake that for an 11. So you might choose not to put your 1s up there. In this case, I would say not. Okay? Or maybe just put 1 up there. Okay? 4 will go into 8 2 times. Y will go into y squared y times. Now, this is dangerous doing that because what you have left in the numerator is 2 times y. So you might want to cross out the whole y squared and put a y up here. So that gives you 2y here, and this is a 1 down here, and just a 3 down there. So 1 times 3 is 3. Either way you do it, you could have done complete factorization. 3 times 2 times 2 times 2, x times y times y, 2 times 2 times y times 3 times x, and then factor out each one and multiply out whatever you got next. Well, there's tons of ways you can do it. Just make sure whatever you do is right. That you're doing everything legally. Okay? Let's go to this one. Okay, I'll show you how they did it first. First thing they did, counted the number of negative signs. Why? Put the minus sign there, because the answer is going to be negative. Okay. Strange. They're going to do that anyway. They're going to do it here, but what they did was 4 times 9 times 8 times, see, to me this doesn't make sense. They multiplied the a times a squared times b, but they didn't multiply the 4 times 9. Okay, 6 times 12, and they multiply the a squared times a squared and give you a to the 4th, and b squared times 1 is b squared. Okay, then they started dividing things out. 4 will go into 12 3 times. 6 won't go into 9. You can do this either way you want to. But 3 will go into 6 twice. 3 will go into 9 3 times. Now you have a 3 up here and a 3 down there, so they divide away. Here you have an a squared here and an a fourth here. And a squared will go to a fourth a squared times. And b will go to b squared b times. If you're going to do that, why didn't you just do a times a and wipe out one of those a squared and you have a squared left? It seems like extra work to multiply them together and then divide them out again. So any way you want to do it. I'll show you the way I would have, but you don't have to do it my way. 4 will go into 12 3 times, and a will go into a squared 8 times. Okay? I think at this point I would have said this a will divide out that a, 3 will divide out 9, that would be a 3. The b squared here, b will go into b squared b times, and that just leaves you, and 3 will go into 6 twice, and the a squared is left over. So what you have here is minus 1. You have nothing left up there, so don't put a 0, put a 1 over 2a squared b. So there's bunches of ways you can do this. You do the way you understand best. Okay? What would be your approach to this one? What would be the first thing you would do? Say again? I thought I heard it. Someone said something, didn't you? Count the signs. Count the negative signs. How many you got? What's your answer going to be? Positive. So what I would do, I would go, make those both positive, so I don't not worry about them again. Not going to be a negative in the answer. Okay? Now, again, the weird ways of doing this in my mind. You certainly can do it this way. 12 times 24, x cubed times y cubed, 18 times 56, x times y fourth. If you want to do it that way, it's perfectly fine. And then they proceeded to 6 will go into 12 twice, 6 will go into 18 3 times. And I guess they did 8 will go into 24 3 times, 8 will go into 56 7 times, and the 3's divide away. So you've got your numbers simplified as far as you can. And they do x will go into x cubed, x squared times, y cubed goes into y4, y times. So you have 2x squared over 7y, which is nice, clean, perfectly fine. Okay? If you don't like writing all that out, here's probably what I would have done. In any order you want to. Again, 6 will go into 12 twice, 6 will go into 18 3 times. Okay? I think I would have next said 2 will go into 56. How many times? 2 into 56. Oh, pull out those black boxes. Huh? 28 times, okay? All right. 3 will go into 24. 8 times. And 2 will go into 8 4 times. Oh, 4 will go into 8 twice. And 4 will go into 28 7 times. So you get 2 sevenths. Write that down. Okay? Now looking at the x's and y's, I see this x down here will divide out that x. I'm going to do these 2 y's here and wipe out that y squared. And there, oh no, that wasn't a y. Huh? I'm sorry, I messed something up there. See, this is the problem with doing that. Let's go back to our y's. Okay, I misread something. Oops. Okay. Yeah, sorry about this. Y and y squared wipes out the y cubed. That's what I meant to say. Okay? So now we have 2x squared divided by 7y. Just have to make sure you don't lose anything. So actually, for bookkeeping purposes, this might be a little deeper, for sure. This, you can sort of lose things easily. So you've already paid your money, you take your choice which way you want to do. Okay? if the rational expressions contain polynomials other than monomials, factor everything in sight, really like we did here. Then your work may take on the following format, which, let's see if we could get the format done. It didn't do a format, but here we go. Here's example 1. What would you do first? What would you do first? Say again? Okay, okay. Now, if you talk about signs, this is a plus, here's a plus, there's a plus, there's a plus. All of them are plus, so the answer is positive. Don't count these signs in here. That's part of the binomial. Okay? So you only count what's in front of the expression. Nothing, 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 nothing. That's all positive. Okay, signs are done. Next. What's your F word? Factor. Is anything factorable up there? That one denominator and that denominator only. So how does it factor? Say again? X plus 2 times X minus 2. Is that what you said? I can't hear well. Okay? Then I see X plus 2 here, X plus 2 there. Nothing else is factorable. Oh, wait. There's a Y and a Y squared. So that gives you that. So in the numerator, all we have left is 1. And what do we have in the denominator? Y times X minus 2. That looks like all you got left, right? You wiped out everything in the numerator, so you got a 1 left. And in the denominator, you have X minus 2 here and a Y over there. So that's Y times X minus 2. Let's see how they did it. Well, they wrote it down again. I can't believe that. They multiplied first and then divided. Okay, fine. It's perfectly fine to do it this way. The main thing they did was factor here. They rearranged everything. That's fine too. Y will go to Y squared, Y times, and X plus 2, X plus 2 go away. You went from 1 in the numerator, Y times Y minus 2 here. They got the same answer. A slightly different form, but all the steps are really the same. All right, any questions on that one? That was example 1. And by the way, I don't say this every time. Every example in the book has in the margin a classroom example. I wish we had time to do those in the classroom, but why I say as soon as you get out of class, go do those. We've just done them in class, do them as soon as possible afterwards, and go from there. All right, let's we'll start next time at example 2. I don't know if there's a slide there. There's not. And homework exercises here. This is a pretty short section. Do any of the odds 1 through 11, do any of the odds 1 through 5, do the following odds 13 through 13 through 17. I think that'll be all you need to do. 13 through 17. Yeah, stop there, 13 through 17. We'll do the rest of those next time. Good deal. Any questions? Sure. Okay. Right? Yeah. Oh, good. Fantastic. Oh, you want to see your test? Okay. Yeah, anyone wants to see the test, you certainly can. I graded some of these. Huh? Oh, that's short. Had you done the test? You did. Okay, let me get the test. All right, let me see. I got some of these done ahead of time and some of them I didn't. Oh, wait. Yes. This is test. Kristen, did you want to see yours? Donna's not here. Jasmine? CJ? No. Oh, you want? Yeah. You want to finish yours?
Yes.
Okay. Yeah, it
Don't
said
you have a
coming.
class, so do I need to?
Yeah,
go
probably
another
next door if that's it.
Okay.
Okay. Okay. Just a minute. Jasmine's not here. Okay. Okay. All right. CJ's not here. Kanisha, you want to see yours? Look like you were through already.
Yeah, okay.
All right, good deal. Okay. Okay, the rest of them should be here. SMA, Seth, Chris. Okay, yeah, I need that back. Okay, good deal. Should put it here. Okay. Madison, you want to see yours? Madison? Oh, yeah. I need them back now because not everybody's turned them in. Justin, Nick, Melba, you don't work on yours. Sometimes it gets stuck. Okay. Tara, okay. Aria, not here. Tequila, did you want? Yeah. Lindsay, there you are. Jay? Okay. You said you're coming back to go. Oh, no. Yeah, I thought you had.
What?
Okay, you're going to have a good score. Okay, Kayla? Essence? Not here. Jayla Webster, not here. Brianna?
Oh, okay.
Okay, I need them back, folks, and Chuck's not here.
Man, I don't like none of y'all.
Huh?
JT.
Oh, you didn't see you. I'm sorry, I thought I already got you. Okay. I go back to the file. I think I already graded yours. Had you started it?
I did.
Oh, you did, okay.
I finished it.
You did finish. These are the quizzes. What's your last name?
Bennett.
Oh, Bennett, that's you, okay. I didn't see JT, okay. Good score. Excellent score, okay. Oh, you haven't taken it. Did you turn in the quiz?
Yeah, I took
Okay. All right, you want to take it next door? All right, good deal. Thank you. Thank you. All right. Got them in my lap. Ah. This is the trouble with having. Well, where's my stat? No, that's not it. That's not it. Here we go. No. I know I had some left over. You didn't start it, did you?
No, I didn't.
Okay. Quiz. CJ. Oh, here it is. All right, you can go next door if you like.